This episode of Hak5 is brought to you by Domain.com.
Hello, welcome to Hak5. It's your weekly dose of Technolust. I'm Darren Kitchen. Shannon Morse is with us a little later on in the episode talking about some Cygwin action. That's right, a little bit of Linux Windows lovin'. And I am actually up in Eugene, Oregon with Peter talking about drones. So let's just kick it over to there. Welcome back to our drone series. To recap, we are building an autonomous platform for awesomeness, and we're using an open source flight controller, and that's where we're picking it up, Peter, because we need to dive in and start setting this guy up. As we talked about in the last segment in the series about the flight controllers, we were talking about some of the sensors, the magnetometers and the accelerometers and gyroscopes and barometers and other things like that, that were, I think we were demonstrating in the Lisa S, which is your really small version of it.
Yeah, this is the smallest, yeah.
We're using the slightly larger version of it?
It's a bit easier to handle because it has bigger connectors and stuff.
So this is the Lisa M.
Yeah, the Lisa M, and it has actually less sensors than the other one, but
it's bigger and has less sensors.
Bigger and has less sensors, but it has enough for us for now. So it contains an IMU called Aspirin, and it contains 3-axis gyroscope, 3-axis accelerometer, and 3-axis magnetometer, and a barometer. So
the only thing that it doesn't have built onto the board is the GPS.
The GPS to do a fully autonomous flight.
And we're going to come back to the GPS because it will support it.
Yes, that's correct. But that's something we will plug in later.
Well, this is really exciting. I want to know, how do I go ahead and do, like, is it simply a matter of pulling it out of the box, plugging in the pins? Or,
well, no.
I mean, I think we have to tell it, like, how does it know if we're using a quadcopter or a hexcopter or something crazy that's a cross between an airplane and a quadcopter?
That's right. So we definitely have to tell it what to do and how to do it and what we are planning to fly with it. It by default comes with just a bootloader, no firmware on it.
What kind of bootloader are we talking about?
It's a DFU bootloader. So
we use the same one in the rubber ducky. It's awesome.
Yeah, exactly.
Super easy to use.
So this makes it super easy. You just plug it in over USB and you can flash and work with it.
So why do we need to flash the firmware to it?
Because there is no firmware first of all on it, but otherwise we have to also tell it what exactly we are doing.
So it's more so than just like giving it, say, a configuration file.
Yeah, so the difference here to some other projects is the Paparazzi actually integrates a lot of its settings inside the firmware so that there is no chance to change it by accident while you're in flight. So the approach is more, okay, we can change some settings to tune stuff, but at the end you want it to be compiled in so that there is no accidental change in, for example, your gains and this thing falls out of the sky.
So we're actually going to be configuring a quadcopter program, compiling it, and then flashing it on.
That's right, yeah, and the process is quite streamlined in Paparazzi because it's an integral part of actually putting something in air. It's actually compiling the firmware.
So what software on our computer are we going to need to speak to this guy?
So we basically, there are already a bunch of videos of how to set up Paparazzi in the first place. You just download a few packages on Ubuntu or Debian, or on macOS there are also binary installers for it. So you download that package and then you clone the Git repository of Paparazzi, type make, and then it compiles everything that you will need, and you should be good to go.
Nice. Well, let's go ahead and take a look at it.
So first thing that we will start, because let's assume that we have already Paparazzi installed on our laptop, is the so-called Paparazzi Center. This is the control center of all our operations.
Right, because Paparazzi is really like a suite of applications.
That's right.
It's more than just like one, configuration script. You've got the build scripts and you've got the ground centers and
calibration scripts and tools,
telemetry tools.
Yeah, that's right. And there's also all the modules and the firmware. It's like an ecosystem, let's say.
Sure. Okay.
So we start Paparazzi, and this is what we are presented with. It is the Paparazzi Center, and it divides in 3 columns.
Okay,
so we go from left to right.
All right.
The first thing that you want to do is to select an aircraft. By default, Paparazzi starts up and loads a few example aircraft for you.
Okay.
So this is this drop-down here, AC for aircraft, and there is a bunch of example ones already preloaded for you.
All right, so like a Hexa Lisa L would be like a Hexcopter.
Hexcopter with a Lisa Autopilot on it.
Okay,
for example.
Versus like our quad with Lisa M, or a quad with a Lisa S.
Or with a Navgo. It's another autopilot that Paparazzi supports.
Sure, I'm even seeing some airframes that are familiar. There's a Bixler up there.
Yeah, there's an airplane.
Yeah, in fact, that's in fact, even the AR drone.
Yeah, we have AR drone in two flavors, actually using the official SDK and not using it, so bypassing their official SDK, because you can get some things done better without ignoring their SDK.
Oh, that's a pretty cool way to just get something off the shelf, like right into Paparazzi. Wow.
Yeah, this is
so it really is malleable. You don't even, for instance, you're just using its flight controller and reprogramming it.
Yeah, that's right. That's right. Yeah, you can cross-compile basically to that.
We were talking about this thing runs on x86. So why is your laptop not in fact flying?
yeah. Why not? Or anything else, or your cell phone, or anything, right? Yeah. So in our case, because for our build series, we will be using certain setup that is using the Lisa M. This is what we decided on because that has good set of features. And for that, we will start with the quad Lisa M2 airframe. Okay. So over time, when you get to it, you basically will replace that set of configurations with your own, and it will basically show your aircraft hangar content.
So this is why you're saying also to git clone, because that way you always get the latest from the repository as far as like configurations for different aircraft.
Yeah, there are stable ones. There's stable releases that have their tags and stuff. And you also do your fork, and then you can have your configurations in the fork. If you make any changes, it is super easy to send pull requests.
In fact, speaking of changes, we will be in fact building for the specific airframe that we'll be getting into in the next segment.
That's right.
We're going to be configuring it, and then we will have that as a part of the download, so it'll just be in the drop-down.
Yeah, we will add it to our examples. It will be in Paparazzi, so we will probably put it somewhere in the comments.
Nice. All right. So on the left side, I've got my aircraft, then I have my airframe, and so
the aircraft consists of several files that are being combined to one configuration of a specific aircraft. So airframe is what airframe? Is it an air drone with which autopilot? This is this part defining the hardware that we are flying. Okay. Then we have the next one is the flight plan. This is something we will get much later into, is when we are flying completely autonomously, what the aircraft will do.
Right, because we can program it like with blocks, kind of if you've ever used like Lego Mindstorm or some of those other, node-based systems. We can really do some pretty powerful stuff with the ground station there, with the flight plan telling it, do this, and then wait for conditions, and then if everything's how we expect it to be,
listen to sensors, and based on that, jump to a different block, and
that's right. Hit the.
It's basically a domain-specific language for those that are that know computer science, and you basically program it in a very high-level terms. You rarely, very rarely, if you have something incredibly complicated, you might need to go into C, but it's normally not necessary.
Okay.
So the next thing is a set of settings that this aircraft supports over the telemetry link. This is a set that we provide to expose the internals to the user while we are flying to do settings. Again, as I said, yes, we compile a firmware and we compile in the default settings so that they don't change, but we still, while in flight, are able to change things that we expose, and we explicitly say that we want to expose.
So we want to be able to make changes to variables mid-flight.
Yes, so we can tune, for example, the controls of this thing so that it is very nice and stable, dynamically while we are flying, and after we are done with those, we might decide, okay, we are done with this is stable, we know that it is the right thing, and remove that setting from being exposed so that there's no chance of changing it.
Cool, okay.
So the next thing is a radio. This is something in our case, because we use spectrum receivers that are completely digital. This is it is completely being ignored, the radio part. This is only needed if you have PPM receivers, namely the standard RC receivers that output the PWM signal that you measure.
So PWM, pulse width modulation, versus using
UART, basically. In our case, we use a serial output of the satellite receivers that the satellites are outputting, and we are just reading the serial digital data directly from our remote control, more or less.
Okay. And the telemetry? And
the telemetry, that's, again, a configuration which information we want to receive from the aircraft while we are flying.
Right, like if we want to know what the battery status is, and if we want to know at what angle is it pitched, and things like that.
That's right. And if you, for example, adding new sensors or gimbals, or you can modify this and say, okay, I have this very special sensor on my aircraft that outputs the flux of the molecules.
Let's go with SSIDs.
Yeah, or SSIDs.
Yeah, some Wi-Fi's.
And we can basically add additional telemetry packets and put them into the telemetry setup and get them to the ground.
All right. So that's the left side is our aircraft. Then what are the other bits?
So the next bit, after we selected that, this is in our case also completely fine. This is a nice default setup for the Lisa M. So next part is basically compiling the firmware that goes onto the Autopilot. And then we have, if you do it ever on the command line, you have make, and then make clean, and make all to compile everything. So clean is the first button, and you can select which target you want to select. So AP is the Autopilot, NPS would be the simulator. So you can run.
Oh, so we can test it before we even burn
the
firmware.
Yeah, that's right. We could test it. We could compile a simulator and run the whole Autopilot on the ground in a simulation.
So your entire flight plan could be running in your laptop without ever a rotor spinning.
Yeah, that's right. That's right. You can test your complete flight plan and that basic settings are right and it is not doing weird things before you even put it on the aircraft.
Okay.
So we select Autopilot. The default flash mode is normally fine, and you can press build, and it will compile the firmware.
Look, GCC, it's actually, like you said, this is C code that it's simply turning now into a, like a bin file or a hex or something to...
Yeah, it's an ELF file,
and
then generates bin files.
And then and so at this point, we're ready to use DFU uploader
to upload it to the Autopilot.
So very similar to flashing the firmware on your router at home, we're going to go ahead and do that here, right?
Right. So the thing with Lisa M, what you do is you have a micro USB connector, and we just take a micro USB cable and plug that in, and we get a nice Cylon pattern.
I love that blink pattern.
So this means that the bootloader is running.
Okay.
And it is waiting for data to be flashed to it. So it detects that you plugged in USB, and it is waiting for you to upload the firmware.
Okay.
When you have it in your aircraft, then you have a separate source of power from the battery, and then
it won't be in.
But it makes it super easy when you have it already in the aircraft, just plugging in USB, and it will automatically go in the bootloader, so you can upload a new firmware if you need to do any changes. So now
let's go ahead and push the firmware.
Yeah, let's flash the firmware. Just press the upload button, and there we go. And it is done. And we see that the Autopilot is initializing. We see the fast blinking red LED is showing that the IMU is calibrating at startup, so it is taking a little bit of time to figure out where gyroscope 0 is, so that it is.
So it's
knows
getting
where
some samples, so it knows where the ground is and what its angle is.
Again, it's all completely configurable what you do. It's like you can switch it off, you can make it longer, you can make it shorter. It's beautiful setup. It's like when you get into the details of it. The green LED is the live LED. It will always blink with 1 second interval, showing you that the firmware didn't crash, basically.
Cool. So it's a heartbeat.
It's a heartbeat, yeah,
nice.
Exactly. And the other LEDs will show also different status, like for example, do we have GPS fix? Is the radio working? Is the battery still working? It's also, again, completely configurable.
Mm-hmm. So that's setting up the aircraft and now building the firmware. So I take it at this point, we're ready to fly? But not really, because we're not about to hook this up to motors and see what happens.
Yeah, no, that's
kind of want to make sure that all the sensors and everything are working, right?
Yeah. It's like I would rather do that. Yes, you could try to put it in, and it's like I wouldn't recommend to do that in any case, I guess.
So how do we get the telemetry back from this now?
So there is a serial port that you connect to. So I have an adapter here. It is an FTDI USB to serial.
Okay.
It's the Floss JTAG, and it has a serial connector here, and we can just plug it into the telemetry port.
Okay.
You just look up on the wiki. There's beautiful graphics showing what is what and what pins are available. And then, after we connected this, we can just execute in the third section of the program a session. And the session is starting up the ground control station.
So a ground control station is showing us what? Is this where we plan our, this is not where we plan our flight plan. This is where we get the live telemetry?
This is your tool on the ground that you, it's your tower. It's your second remote control, more or less. Mm-hmm. It's the computer program that is the remote control when the aircraft is flying completely autonomously, let's say.
Okay.
But we can use, it has a lot more information about the status of the aircraft. So this is something you would want to start first to see that everything is doing well.
Right, so even though we're of course we're going to start out flying manually with a controller, with a remote, but it is nice to see what it's feeding back.
Yeah, we are basically
then later when we get into autonomous stuff, we'll
taking a look inside its brain. It's like, what are you thinking?
All right, time for your thoughts. Well, what is it thinking?
So, the GCS divides in several sections. We have the map, that's in the black area. We can just load the maps. It's just some random place because we don't have a GPS plugged in.
Oh, let's see some random place then.
Some random place.
Hey,
random
we're
place.
in some street. Cool.
Yeah, we can zoom in into the map and then we see basic flight plan containing.
And so where are we?
We are this quadrocopter in the middle. Let me move this waypoint here. So we see this quadrotor with the arrow in the front.
So that arrow so that line is pointing towards where
we're
facing?
No, this is its track. It's where it came from.
I see.
But it's just an artifact of actually starting up where the waypoints didn't update yet. And the second thing that is also interesting is the PFD. It's the virtual horizon. So if we take the Lisa M in our hand and if we tilt it forward, this is the imaginary forward, of course.
Oh, I see.
Tilt it forward, and we see the horizon is on
the... Oh no, we're pointing towards the ground.
Yeah, we are pointing towards the ground.
Quick,
and
pull up,
it's
pull
brown,
up.
pull up. And the sky.
Oh, wow.
And then we tilt it left, so we see the horizon is tilting. This is... The horizon, you have to be careful because it is easy to get confused. It is from the perspective of someone sitting inside the aircraft. Okay. So you are basically imagine yourself being teeny tiny and sitting on the autopilot.
On the top of the PCB.
Yeah, on top of the PCB and then looking at the horizon. Then
which I guess would kind of illustrate why it's important that the PCB is secured to the frame.
Yeah,
not flopping around somewhere.
Because this is as we said, your copilot. Mm-hmm. So don't let him flop around in the aircraft.
It's gonna be a bumpy ride. Okay, cool. So what is the sensor that's feeding us that telemetry back?
So this is already a fusion of several sensors together. So we have also the magnetic orientation is showing when you look at the map.
Oh, so up here on the map, I can see that arrow just changed.
Yeah, if you rotate it.
Okay, so
it will point.
There's our yaw.
So we have yaw.
And then down there we can see the pitch and roll.
Pitch and roll, yes. And so this is the basic information about how the aircraft is pointed. And then each aircraft in the GCS will get also a block here on the left lower corner, with information about its status. So we get an orange block about the battery charge, so how much voltage. We don't have a battery connected at the moment, so it's 0. Then what is the status of the aircraft? Is it in kill mode? Is it in nav mode?
Kill mode?
Yeah,
What is kill mode?
Kill mode means...
We don't want the drones in kill mode.
On the ground you want. You don't want it to come to life suddenly without you wanting it.
Oh, so kill mode is like no rotors are spinning.
No rotors spinning, and please don't change that fact.
Okay. It's not fire the missiles mode.
No,
Got it.
No. That's,
oh, and hey, look, AGL, above ground level.
Yes, that's you take the information from the GPS and the barometer together, and then you can calculate the altitude. So you get the AGL information.
So when we incorporate this live telemetry back to us, even with our remote, we're already adding a lot of value, because you can see in the sky, you're like, oh, there I am, I wonder about how high I am.
Yeah, that's right.
Look down, there you are.
Yeah, that's the beautiful thing. It's when you, even when you are flying completely manually, and having a GPS too is a very nice thing, and having the telemetry is also really useful. Imagine you do something wrong, let's not do anything wrong, but it flies away and you want to find it. It is nice to have the telemetry where it is.
Oh, so it's like, hey, I'm going for a Slurpee. Peace. Like, where did you go? And then you've got like the GPS coordinates of where it ended up.
Yeah, it's like, it's useful.
It's like hanging out in a field with all the other quadcopters. All right.
And the rest is related to also the link quality and so on and so forth. But we will discuss all the details when we just continue building it up and try flying it.
Well, that's what I'm excited about, because in the next segment we're actually breaking out the kit. We've got a really cool kit, in fact, and it's time to actually start building this and soldering things together and putting motors in, and suddenly things are going to start spinning.
Yes.
So stay tuned for that, but we're going to take a quick break. You know, there's only 10 kinds of people in the world. Those who don't understand binary, and those who know that when you've got a killer idea, you need to snag yourself a domain name and web hosting fast. And Domain.com, let me tell you, they've got the quickest domain discovery system and easy checkout process to get you up and running in no time. And I love the guys over at Domain.com because they're easy to use, they're reliable, they're affordable, they're huge on social media. You can tweet them at Domain.com and see why we think they're just such a fun place to do business. And get this, they're huge fans of Hak5, so they want to hook you up. If you use the coupon code HAK5 at checkout, you'll get an extra 15% off. So when you think domain names, think Domain.com.
We're back, and it's now time for the trivia question of the week. So last week's trivia question was, who coined the term robot? And the answer was Joseph Capek, C-A-P-E-K. Now this week's question is, what was the first commercial application of microprocessors? You can answer that over at hak5.org/trivia for your chance to win some awesome Hak5 goodies. Cygwin. You all know it and you all love it, but for the people that don't know it, I decided to talk about it today. It's been around for years, since 1995, I think, so kind of a long time, and a thought occurred to me. We have never demoed Cygwin on the show. So first off, what is Cygwin? Well, it's a GPU licensed open source Linux-like environment for anybody that's running on a Windows machine. So whether you're running Windows 64 or 32-bit, you can install this baby. Now I've installed it on my 64-bit Windows 8.1 laptop and it runs just fine, which is great. With Cygwin installed, you can gain access to a bunch of standard Unix utilities. So you can use it with Bash or the Windows command prompt. Yay, so cool. And this could be incredibly useful if you want to Say you need to work on a Windows box at work and they don't want you to install Linux. Or you want to be able to use original Linux commands and you don't really want to use the new Linux ones, or you don't want to learn that completely new tool set for Windows. I mean, who really wants to use dir when you can use ls? I mean, come on, people. It is a DLL file and it works as a Linux API layer with Linux API functionality. So, how do you install this baby? Well, you go over to cygwin.com, very simple website. Up here, you go to install Cygwin, and you gotta know whether you are 32-bit or 64-bit. My computer's 64, so I just installed the 64.exe version. So super, super easy. Once you have that installed, and I'll show you what the installation looks like, go over here to my downloads, and keep this file, don't delete it, because it will come into use later on. So I'll hit yes, and you basically just run through the installation. Click next a whole bunch of times, choose all the defaults, so that way you don't have any kind of problems. So just install from the Cygwin website, 32 to 64. Installation should not take too long, and you'll need to choose a mirror site to download it from, and during it you'll see this crazy page that has a bunch of optional packages, but for now just stick with the default, just don't go any nuts. And don't click all of them because it'll take like 14 hours to download the entire thing. We don't want to do that, so just click next and move on. So for me, installation took about 15 minutes and I created a shortcut on my start menu and on my desktop to make it super, super simple. So once I have everything installed, I just go over here to Cygwin 64, the terminal. Yay, it's so pretty. Click on that and you get a simple little terminal. So once you get Cygwin installed, it's fairly similar to using a regular Linux command line interface like bash. So you can try out some normal commands that you normally use. Like for example, I can type in pwd and I can see I'm in the home/Shannon folder. I could use cd and then ... to go back if I wanted to. Let's see, what's in here? ls, not dir, Shannon. So I could go back into there if I wanted to. I could use touch to create new text files if I want to. I could do pretty much anything that I want to. Now, of course, we learned a lot of these in my Linux Terminal 101 series on Hak5, so make sure to watch that if you need a brief overview or if you forgot any of them, which I kind of did. And also keep in mind you may need to run as an admin to be able to run a bunch of the different commands. Just, right click, run as admin, super simple. So let's do something simple. All right, so I'm gonna go ahead and close this. I'm gonna run as an admin. So I will select yes. All right, so we got a nice big box for us to work in. So basically here, I'm just gonna create a text file. I wanna read from it, and I'm gonna maybe write something new to it. So let's see, first off, where am I? Okay, so I have a text file already in that folder that I'm in right now. So this is my Cygwin folder, and if you're wondering where you end up under C, Cygwin, Home, Shannon. And there's my todo.txt. So if I want to create a new folder or a new file, I'll call it touch. Let's call this wedding.txt. So now if I go down here, okay, so I have wedding. All right, so, and now I want to, let's say I want to add something to it. So I'll type echo, whatever I want my text to be, remember to pay wedding venue fee, because that would be really crappy if I forgot to do that, and then add it to wedding.txt, and you can just tab over just like you can in Linux. Press enter, so now I can use vi wedding.txt, and there it is, remember to pay wedding venue fee, and if I hit wedding, there it is, remember to pay wedding venue fee. So yay, it works totally, just like I thought it would. Control Z gets me out of there. So super, super simple, everything works as it should. Now say you want to customize it, you want to put some new packages in, you want to maybe change around the terminal because you don't really like what it looks like right now. Now the terminal that you get sent to whenever you download Cygwin is called Minty. But you have other options as well. You can use alternate programs like Console. You can also use Minty, which change the look and feel of the program. So you have lots of options. You can also download new packages. So this is why we want to keep that setup.exe file that we opened previously. So if I go down here to setup, keep it at all users, click next a couple of times, direct connection, yes. Same mirror, I'll keep it on the same one. So it's going to download real quick if there's any updates to the setup file. Now we have this really big screen that has all these packages that you can choose from. So these are kind of crazy, and if you don't work in Linux a whole lot, it might be kind of confusing. So I would say add things on as you need them, because you really don't want to download all of them at the same time, or you'll end up with just a bunch of really, really long wait times. So I'm going to go up here to Games, and you can see I've already downloaded one right here. You can also uninstall it, reinstall it, or just keep it the same as it is right now. I'm going to choose this one. So I just clicked on Skip, chose to download it, the bin, and 24K, that's like tiny, so that's good. Click Next. And now I'm downloading a new package. So obviously I'm not using apt-get like you normally would, but it works pretty much the same. It just has a GUI interface. So once this is done installing, click Finish. And I'm going to reopen this. Yes, close anyway. I know that's totally bad, but I'm going to close it anyway. And I'm going to right-click Run as admin again. Yes. And I think that one was called Ninvaders, yeah. Okay, so this is some kind of video game. Ah, ASCII, yay! Ah, there we go. Oh, this is great! Oh my gosh, this is so cool, you guys! Look, it's like having an arcade game on my computer. Except it's a lot easier. Ha ha ha! Okay, well, before I get too involved with this, I hit Control-Z to get out of there. Let's see, I can play my robots game if I want to. So this one's a little bit more tricky. I haven't memorized all the different lines yet. But apparently you're supposed to just stay away from all the little robots. Stay away from me! There we go. No! Oh crap. Oh crap. He's gonna kill me. A. Doesn't work. Die! Transfer. Oh, there we go. Yay! Okay, so that works too. That was fun. Okay, I'm done. So, yeah, as you can see, things work like they should in Linux, but you're on your Windows machine. That's so cool. Yes, I know that you could, use a VM, or you could totally use VirtualBox or whatever, but this is still really cool if you just need to work in the terminal and do a few fun little things on your Windows machine. Now tell me what you like most about Cygwin, because I want to know. So send me an email over at feedback@hak5.org, or you can comment below. Coming up soon, we have more fun stuff, but first, let's take a quick break.
That just about wraps up this week's episode of Hak5, but I want to let you know about a couple of cool things happening. First of all, June 8th, we are having an awesome hacker brunch. It is going to be here in the Bay Area, so if you're in San Francisco Bay Area, come on out. hak5.org/brunch is the place to find out all the details, but I hope to see you on Sunday the 8th. Also, if you are interested in hacking and camping and soldering and learning to hack and learning to solder and learning to camp and all of those things, you have to come out to Tor Camp. It is just, it's a spiritual hacking experience. I can't begin to tell you enough about how amazing it is. And so I encourage you all to go to torcamp.org and find out. It's coming up this July and it is going to be amazing. What else do we have on the docket? Let's see, get this. We have hak5.org/follow. There's all the places you can find the ways to follow us on social media. And HAK Shop, that's where you can continue to support us directly and make this happen. You are our shareholders. We are so thankful that we can do this and support it directly. And so get this, I'm really excited because we actually have a fantastic new product. I've been doing a bunch of testing of 3G modems with, of course, our Wi-Fi Pineapple. And this is something brand new, exclusive to us at the Hack Shop. It's called the Port Pilot. It is wonderful. This is not just like an amperage and voltmeter, but it actually has a lot of intelligence. You can cancel data from happening if you want to protect your phone from any possible juice jacking attacks. And also logging. There's a micro USB port where you can plug it into your computer and actually record power data. It's a power analyzer. This thing is wicked. I love this thing. I can tell right now, hey, this 3G modem is only using 130 milliamps. That's pretty fantastic. My battery's not gonna die for days. Anyway, hakshop.com is the place to find out more about that stuff and how you can support us directly, and I thank you so much. And as Shannon and I remind you every week, trust your technolust.
Sounds like he's coming up the stairs. I hear a bunch of banging noises out there. It's a monster. He's going, oh.